Hello everyone, this is the Left Right Center game video made by Group 60 of the Engineering 6 class. My name is Kavish Purohit.
I'm Morgan Finley.
I'm Angelina Jives.
I'm Saj Kelly.
And today we're going to talk about this game and how the code works.
So the rules of the game are pretty simple. The game requires at least 3 players who start off with 3 chips, and each of the players will roll a dice, and the order of the roll will be in clockwise order. The number of rolls will depend on the number of chips a player has. So if a player has more than 3 chips or equal to 3 chips, they will roll the dice 3 times. If the player has only 2 chips, then they will roll the dice twice. And if the player has only 1 chip, they will roll the dice just once. Each roll means a different thing. If you roll a 1, 2, or 3, you don't do anything. You don't pass any chips to anyone. But if you get a 4, the player situated on your left will get one of your chips. So you will pass 1 chip to the player on your left. If you get a 5, you will put 1 chip of yours in the center stack. And if you roll a 6, then you pass 1 chip to the player on your right. And then after your turn is over, the next player will get the dice and they will keep rolling it. This goes on. And until only one player is left with chips and the other 2 players are left with 0 chips, that's when the player with the chips is declared the winner.
So if we hit the start game button, an audio will play indicating that the game has started. So as you can see, each of the tables for each player have initialized with 3 variables with none in the center, and our table is blank. So player 1 starts the game by hitting the player 1 roll button. An audio is played with a dice sound. 3 dice images appear corresponding to the roll value of each individual dice. In our main table, a row is created for the turn number, as well as displaying the values of each dice rolled. Player 1 can then hit end turn, which gets rid of the dice, and as you can see at the end of their turn, each table displaying the player score value has updated corresponding to the number that they've rolled. So player 2 can do the same thing, hit player 2 roll. A new row will be added to the main table, showing that their roll value. 3 images will appear with their value of the roll. Player 2 can hit end turn, and once again, the values have all updated on the table, including adding a chip to the center. If any player at any point in the game needs to be reminded of the rules, they can hit the rules button, which will bring up the starting image again, displaying the rules of the game. Once they're done reading, they can hit continue, and as you can see, each table is still the values from before they hit the rules button, indicating the game is continued rather than starting over. So we can now go to player 3's turn. Player 3, same thing will happen, new row will be created, roll displayed, 3 images appear, and all the table values updated. We can then continue this process by going through each player roll really quickly to get to the end of the game. As you can see, that roll for player 2 at the start of their turn only had 1 chip, so they only rolled 1 dice, only 1 roll appeared in the roll category, and only 1 image showed up. As you can see, for that turn for player 3 started their turn with 0 dice. They rolled 0 dice, meaning that there was no value appearing in the roll column, and no images appeared. So as you can see, on player 1's turn, they lost the remainder of their chips. Player 3 had no chips. That means player 2 has won the game. So once that happens, an audio will play indicating that the game is over and that player 2 has won, and an image indicating player 2 has won overlays the screen. And if the players want to play a second round, they close out the game and restart the code, and it will essentially start up the same window as what KP started at.
Now to take a look at the core components. First, we have the properties of all the variables set so that they can be accessed anywhere in the code. Then we have the startup function, in which it initializes all of the distributions of the chips, and it starts the turn number count for the main table. Each player's score table underneath each game controller is updated to match the number of chips that each player has, so that you can see the initial distribution of chips, and a few reach components are added concerning images, and I'll have Morgan speak on that briefly.
So the way our GUI works for our animation is essentially all images are invisible until the code makes them visible again. So in the start function, this is defining all images in the GUI as invisible, meaning visibility equals off. So in the images of player winnings, each player 1, player 2, and player 3 win screen is turned off, and then below that, every dice in every single position underneath the main table is starting with an off visibility.
After that, we have the player 1 roll button. This is triggered when the player 1 roll button is pressed, and we have a dice sound triggered.
So this code starts by looking in the directory of sounds, and then it will read the sound file we selected. In this case, for the dice sound, it will read the dice.mp3 file in the sounds directory, and it will then play that sound whenever that button is pushed.
Afterwards, the turn starts. It first checks if there's a winner yet, because we don't want the game playing if there is a winner. Then it determines the number of player rolls that the player has according to how many chips. If they have 3 or more chips, they have 3 rolls, and if they have less, they have the corresponding amount of rolls as the amount of chips they have. It creates a random integer set of each player roll, and then we have code that goes through each dice and disables or enables images that correspond to the dice rolls.
So this if nested switch statement goes through each location in the random dice array and toggles the visibility based on what number is in that array position. So if a player has rolled 3 dice and they roll 1, 2, and 3, the first position, the dice roll visibility for number 1 will be turned on. In the second position, number 2 will be turned on, and in the third position, number 3 will be turned on, and all other dice will remain invisible.
There's 3 different statements because they go through the amount of dice according to the length of the array of the random integer set. Afterwards, the actual turn starts, and it checks first if there is a winner, and then it distributes the chips accordingly to each roll. It goes through the entire set, and it either passes a chip to the left, right, center, or does nothing at all. Then it creates a string of each dice roll, and it's displayed in the main table, and all of the data is updated here. And then it ends the turn. And because this is outside the if statement, if there is a winner, it will go to this and it will display the winner banner. I'll have Morgan speak on that briefly.
So the if statement below this function scans through if there's a winner and will toggle the corresponding win screen. So in the first if statement, this is for player 3 wins. It will toggle the player 3 win screen and then stop the dice sound from playing because we don't want 2 sounds playing at the same time. Once that dice sound is stopped, it will search through the sound directory again, find the sound that we've indicated. In this case, it's sounds/winner.mp3, and it will then play that. The else if statements go through the same code line and will do the same thing for player 1 and player 2 win screens.
All right, and that pretty much concludes the code. Similar code is written for each player, but the direction of the pass is changed according to the player's position on the board. The last part of the core component is another reach component I will have Morgan speak about.
So at the start of the game, the rules screen is enabled, and as well as the start game button. By hitting the start game button, it untoggles that start page and the button itself, making them invisible again. Then the sound will play by searching the directory again and playing the start sound. Below that, the rules button, basically when that button is pushed, the start page will remain visible again, and then the start game button will remain invisible because that start game button initializes all the variables, and that would make the game start over with 3 chips for each player. A new button appears called Continue Game Button, and below that, when the Continue Game button is pushed, it makes the start game page invisible again, as well as turns off the visibility of that button itself. The end turn button for each player remains the same throughout the game, and essentially what that does is it goes through all of our image files and toggles every single one of them off, no matter what the player has rolled.
And that concludes the code.
Okay, so for the ThinkSpeak portion, we created a new property, made it private, created a new channel, which is right over here. Input is channel ID, write API key, read API key. And then at the end, we created a button in order to, once after every turn, we would update this, we would update ThinkSpeak with the chip count of each player and the center chips in order to basically create a scoreboard system. However, yeah, this code over here shows it, where like each one of these values are corresponding to each table value, which represents how many chips a player has and the center has at any given turn. And it's sent directly to each of its corresponding fields. However, when we tried implementing this, our game would only run for 1 trial, and the ThinkSpeak could not read the data for some reason, and it gave us no actual error. And so it would just bug our whole game. So we got the code in there, but we had to remove the button. And so ThinkSpeak did not totally work for us.
Thank you so much for listening to our presentation.